Try to do this question. This is question 1D. The first step we have to do is put this into a proper form. What that means is you convert terms like this, which it doesn't have plus 1, into s on 4 plus 1, and then you have to times by 4 later. And then what we want to first do in a Bode plot is graph the gain. So to get the gain, we do gain equals to 20 log 10 of the h, which is the transfer function. So also, because of the log rules, we can split this up into the separate parts of the transfer function. So I'll just do that now. It's usually best to put the constant first because later on it's all going to be in order. So 20 log 10, 10, 1 on 4, plus 20 log 10, 1 on s. That will be this term here. Cross them off as we go. Plus 20 log 10. Which one's next? I'll do this one here, which is 1 on s plus 1, plus 20 log 10, 1 on s plus 1, plus 20 log 10 s on 100 plus 1. Now this equation is quite a long one, so the next step, what we want to do is break it up into the boundaries of the break frequencies. The first one would be 0 to w to the break frequency of this is 1. So from the constant term, which is always going to be there, it's going to be 20 log 10, 1 on 4 equals to 20, still 20 log 10, 1 on 4, that's minus 12.04. And we're also going to have this term here and this term here. Were we? Nope. We're only going to have this term here, which turns on. So our gradient of our line will be dm, which means the change of gain over the change of frequency is going to be equal to minus 20 decibels per decade. And now I've been wondering all day where this 20 dB can come from and how you can prove it. Basically, so if we are taking the log of this is actually magnitude. So we take the log of the magnitude, we actually can turn it into this. Since this, we're just basically putting that to the top and moving the minus outside, and then taking the magnitude is just squaring the real and imaginary components, and then taking the square root. Then we get this term here. Now, for low frequencies, which means that 1 on t, we can see that this roughly equals to log 10 of 1, which equals to 0 decibels. And in addition, if w is a lot bigger than 1 on t, we're going to see that this term actually dominates the whole equation. So it's going to be equal to log wt only because it dominates this, and once you square root it, it's going to be left with wt. And then that shows that just say at w equals to 1 on t, the log magnitude is equal to 0 decibels, and at 10 on t it equals to minus 20 decibels. Because if you sub this into here, you're going to find that that goes to 1 and that gives you 0 decibels. Sub into here, now we get log 10 to the power. So I'll just write it out. So you get log 10 to 10, which is 1, so you get minus 20. And then from this we can show that this is actually decreasing by minus 20 decibels every decade. So that's where this actually comes from. So getting back to the question now, we're going to have the next interval from 1 to, let's see, 1, 2, 4. Yep. And then this point we're going to have, let's see, actually I made an error here. Since this turns on at the pole, it's going to constantly be, if it's not shifted, it's actually going to be actually no, that was right.